all of these types of factoring problems here with the negative or rational powers are all set up and solvable the same way. Okay? The process is look to see how your groups are arranged. So when I look at my numerator, I have two groups of factors separated by a minus. And that is going to play a role later, but what you want to do is find, are there any common factors between these two groups? I would suggest you start with the smaller of the two groups. So to me, the right one is a little bit smaller. So let's see, number-wise, I have a negative 3. In my second group, in my first group, I have negative 2 times 2, which is negative 4. Are there any common factors between negative 4 and negative 3? No. So move to the next factor, x plus 1. Is there a common factor of x plus 1 in each of these groups? Yeah, so I can take out an x plus 1. When you factor out, you're always going to take out the smallest power. The smallest power is the number that's furthest to the left on a number line. So which number is furthest to the left on a number line, 3 or 2? So x plus 1 squared is my common factor. Move to the next base, x squared minus 3, x squared minus 3. So again, I have this common factor. I can remove that, always taking out the lowest power. So which is lower, negative 3 or negative 2? Now negative 3 is further to the left on a number line. Okay. Now, you've heard me say this before in other factoring problems, but when you remove any common factors, whatever's left inside the grouping symbols has to have the exact same form as the original. One group minus another. Okay, so let's just see what's left in these groups. Okay, from the x plus 1s, we took out or factored out a power of 2. Factoring is dividing, so when you divide exponents, what do you do with their powers? Subtract. So we're going to subtract a power of 2. And then with the x squared minus 3's, we're going to subtract a power of negative 3. So minus a negative 3 changes the sign, becomes a plus 3. So if I want to see what's left in this first group, this entire group of factors canceled. 3 minus 2 is a net 1. So I have 2x times a negative 2 gives me negative 4x times x plus 1 to the first. And let's see the same thing with the second group. We took out 2x plus 1, so minus a 2, which removed that whole thing. We took out a negative 3, so minus a negative 3 adds the opposite. So in this second group, we have a 3, and we have an x squared minus 3 to the first. Okay, all of this is divided by x plus 1. When you take a power to a power, what do you do with the powers? Multiply, so 3 times 2 gives you 6. Okay. So as we continue to simplify this, anything with a negative power can be moved to from the numerator to the denominator, or vice versa. Change the power's sign from negative to positive. We also have this common base of x plus 1, so these two x plus 1's can cancel with 2 of these, leaving a 4. And then finally, distribute our negative 4x through here. We get negative 4x squared minus 4x. Distribute our negative 3. We get negative 3x squared. Minus a minus becomes a plus 9. So our overall numerator winds up being negative 7x squared minus 4x plus 9. And our denominator, write our first degree polynomial factor first, and then our second degree factor next. Okay, so this would be our simplified form. You could check and see, can we factor this numerator at all? Well, a negative, the way to test it and see is if you take your leading coefficient times your constant, negative 7 times 6 is negative 63. Are there two factors of negative 63 whose sum is the middle term, negative 4? Well, negative 9 and positive 7. If you borrow 3 from here, you get negative 21 and 3. So there's no combinations as far as those go that will give you a sum, outer and inner terms of negative 4. So there's no factors. No factors got canceled from the denominators here, so this is your simplified form.